Well, hi, good morning. Thanks so much for joining me in my shop here. It's December 12th today. So, what to do with this radio? I think I'm going to continue trying to have a little bit of fun with it and explore its operation, not so much specific to this radio, but kind of generally. I want to try to use this radio to find some general truths out about radios. So what I really want to do is take the theoretical side of things and see if there's a practical way of seeing them or proving them or whatever. And what I'm really talking about is the response curve type stuff here. So I think the first thing we're going to do is look at a response curve. Found an old document containing examples of response curves from radios. Look at that, talk about it a little bit. Then we look at the schematic and see what's going on in this radio, and then try to figure out how it is I can examine these questions about the shape of the curve and stuff like that, and ultimately how come this radio could hear image signals, and how come that other radio I had in here in the last video with an extra tube in the front seemed to work pretty much the same in terms of rejecting image signals. So that's all kind of curious to me. I mean, I've read a ton of stuff on this over the years. Like anybody who does this kind of work, you have a notion of these things, but how often you really run into their effects is, well, maybe you run into them without knowing them. Let me just stop at this point. Get my crazy diagram out from yesterday. You know, that's too messy. Let's just take a look at something here. One of the observations I made, probably in the very last video, was this thing about, so that's the AM band there, and the signal we're interested in or listening to is here. Okay, local oscillator is sitting here, and the image is going to be out here. I'm not sure I can remember the frequencies, 1055, 1510, and 600, I think. I can't remember the exact numbers here, but the interesting thing was, as I tuned the radio through the signal here, you could hear a falling and rising signal, a tone that went, only not to be confused with the ordinary moving of the front end tuning of the radio across a signal, which also makes a similar sort of noise. The noise kind of follows that pattern, like that. I'm talking about an actual tone you could hear, and I can't whistle well enough to produce a tone, but there's an actual tone that was going like that. You tune back and forth, you can hear this. Now I've heard this in lots of radios, and I've kind of always wondered what the heck that is. And what I resolved in my head anyway is you're definitely hearing an influence from an image signal. This characteristic sound, this pitch going down and back up, can be figured out. And we'll do this very, very quickly here. So let's say everything is tuned exactly right. So the image is appearing right on top of the signal you're interested in. And this is exactly 455, and that's 455, and the IF is tuned to 455, and everything is kind of as normal as it ever could be. Then when you tune in the 600, even though the 1510 is coming through, you probably won't hear anything because you're at the lowest point of this pitch, which is 0 cycles actually. Now let's say you tune the local oscillator 1000 hertz that way. So now it's at 10,056. So what's happened now, it's here. The distance between here and this signal is now not 455, it's 454, and the distance from here to here is 456. So under this circumstance, a 456 signal and a 454 kilohertz signal will show up together in the mixer tube. You mix these two together and you get a 2 kilohertz separation. 2 kilohertz. 2000 hertz. So starts at 0, rises up. Starts at 0, rises up. So in effect, as you tune back and forth across this, you'll hear this. So I'm thinking now, if you do hear that tone, it has to be kind of a sine wave sort of tone going with it. You're almost certainly hearing an image up here. If you have another interfering signal, not up here, not an image, just another signal right here, maybe a noise signal, also, let's say 2 kilohertz apart. So you have your signal you're after at 600, so there's a carrier here from some broadcast signal, and then at 602 there's a noise signal. There can't be another broadcast signal until you get to 610. But 602 there could be a noise signal. These two will go through the radio, they will mix, and they will produce a 2000 hertz tone also. The difference is, this is the point I'm trying to make, if you tune through this situation, this 2000 hertz tone shows up, and that's what you hear. You hear a 2000 hertz tone. It doesn't do this. Whereas if this situation is occurring, you'll hear this. That's my theory. I think I got it right. I think that's a really important observation, because then it becomes a simple matter of tuning your radio after it's all fixed up through a few stations and listening for this kind of sound. Of course, which kind of sound? Of course, this thing is only going to work if there is a signal out here. You need something out here. And that's right, Peanut. You gonna come in? You wanna come in? Come on in. No, I'm not coming out. Sorry, man. I'm closing the door on you. Life with a cat. Okay, so next thing we're going to do now is we're going to take a look at a standard curve, some curves I found on the internet, which I think will help us understand this stuff a little better. Okay, so I found this chart, believe it or not, on Radio Museum. And you can tell by the way it's printed. It's an old chart. This is from a long time ago. So the title of this is, here's what it says: How the overall selectivity, reduction of response to frequencies off resonance, of a TRF receiver increases with additional tune stages. Now, the radio on my bench is not a TRF receiver, but it kind of is at the front end. So I think we can still pay attention to this chart, no problem at all. So let's see what we've got here. Resonant frequency right in the middle. Kilocycles off resonance. So this is 5,000 hertz, 10,000 hertz away, 15,000 hertz away, 30 kilohertz away, 30 kilohertz, 30,000 hertz. Okay, think a bit about that. Peak value at resonance. Now, if you notice the way they've done this chart, they put 100% here. This is not typically how these charts would be shown, but they do some decibel scale out here or something like that. And I think that's why you're seeing this curving back like this, and it looks like it's going to approach the zero line asymptotically along here. But I think if you put this in a logarithmic scale, you would see that these lines just continue down, 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 for basically never to reach zero because of the way that scale works, I think. So there's three curves on here. They've got some indicators here, you can see, marked out. Those are at the plus and minus 5 kilohertz mark. For some reason they've marked those out. 1 tune stage, 2 tune stages, 3 tune stages. That's what's going to make this really, really helpful. So if we look at the 1 tuned stage. So in the radio on my bench, you could think of this as the antenna on the back. No, there is no coil antenna. So this tune stage could consist, first tune stage could consist, and we'll look at the schematic in a minute, of simply the antenna wire and a capacitor. It could also be antenna wire, capacitor, and a coil. There was also a transformer involved, and it's a tuned transformer on the secondary. So the whole thing gets a little complicated here about just what kind of curve you would expect. Would it be this one for one tuned stage, or maybe it's this one for two tuned stages? You can see that as you add tuned stages, the effect is diminished. The improvement is diminished. So eventually adding more tuned stages just isn't going to buy you much benefit. So we just look at the one here, and we go from, let's say we go to this point. So this is 30%. Now let's think about this. Let's take the 50% mark. If you're listening to a sound, and the sound is cut from 100% to 50%, you'll notice it, but it won't be much. Your ears will hear that as a minor drop in volume. They certainly wouldn't. You would never say it was cut in half. That's just the way we hear it. We don't hear the way this chart is laid out. So in fact, in my mind, on a chart like this, let's say the 50% point is, everything above it is all one. That's a stupid way of putting it. I don't know how to put it. I sort of lost my way of explaining this just now. But it's not to say when you look at this curve that when you get to 50%, half the sound is gone. That's not what's happening in your ear. So the 50% mark, just following on that idea, is way out here, plus 20. Okay, so now maybe I'm interpreting this incorrectly, but I think if you had a signal out here, the same strength as here, so you had a signal here and a signal out here at the same strength, this signal would be cut in half because of the curve here, but that half would still be pretty darn strong. And for sure, you would hear it and it would interfere and all that kind of stuff. Now, normally what's out here is part of the audio program. The audio program is contained pretty much in here. So you go 5 kilohertz. So if you had a 10 kilohertz tone, which I think is too much for a regular broadcast AM radio, that tone would produce a sideband out here. But typically radios, I think, are running in this area, and if they're badly aligned in that, they might even be running tighter in here. The only thing that's out here are interfering signals. Now, everything that's out here, there could be another radio signal here, there could be another station here, another one here. They're all being suppressed, and much more suppression takes place in the radio, in the IF, and here and there and everywhere. The image thing is a different matter altogether. The image is like a signal that cheats its way into the radio through a, what would you call it, a back door, if you like. And that's happening way out here at almost a megahertz away, not 35 kilohertz, almost a megahertz away, because it's double the IF. So, if we pretend this signal is 600 again, as we've been experimenting with, then the local oscillator is out here at, was it 1055? So where would that be? So this would be 600, 605, 610, 620, 630. How far away would 1050 be? Way off the chart here. And then on the other side of that, an equal distance away further, is that image signal. Wow, my gosh, this must be down to almost nothing. It must be way down by then. Of course, the curve here is kind of indicating that when you get down near the bottom here, you can go a long ways out and a little bit of signal still making it in. If you follow that reasoning, you can use the percentage chart. So what this says to me, and obviously it can't be true from the experiment yesterday unless there's something going on with the radio, there's no way you should hear an image. It should just be suppressed to the point where it's inaudible. Now another factor here is how strong that signal was that I was pumping in there. It was really strong. So it could be that I just raised the image signal off my signal generator so high that it came through, and no signal on Earth would ever be that loud or ever be heard. And there's a little bit of truth to that. Another possibility is that this curve is related, well, it says right up here. It says on it somewhere. Here we are up here. Frequency response of a characteristic of a single tuned circuit depends largely on the Q of the coil. Q of the coil. And what they're really referring to is the resistance in the coil. So if you have a coil made of very, very thin wire with a high resistance, this curve might be lower, like this. In effect, it's flattening out. That's what it's doing. And you're losing the peak. The sharpness is disappearing. This is a very important factor. In the case of the radio in front of me, this basically, what is this? Wow, this again, there isn't any coil. The antenna is a wire, and the coil is a little transformer, perhaps. Well, we'll sort this out when we look at the schematic. So again, so how much improvement is this? It's hard to say on this chart. I almost get the impression that if the radio's Q in the front end resonant circuits was really high, there's no hope of hearing ever in any condition an image signal. So we might question the Q of this radio, and is it working properly, or is it where it should be? Has something happened to reduce the Q? I'm not sure what could happen, to be honest with you. Okay, so let's take a look at the schematic now. So here we are in the front end, and we're thinking about those curves and Q and all this kind of stuff. So I have a little bit of trouble analyzing this whole thing here in my head. I see a number of resonant circuits. So the antenna itself has a capacitance to earth, a small capacitance to earth. There's a coil with some amount of inductance. We don't know how much it is. So maybe there's something going on right between the antenna and this coil. I doubt that. The antenna is uncontrolled. The amount of wire attached to the radio is uncontrolled. So would the radio designer attempt to resonate the antenna wire in this coil against this capacitor? I kind of doubt it. I think this capacitor is in there more for safety reasons. A very, very small capacitor. But I don't know why it's there for sure. Maybe it's resonating with this. Or maybe it's resonating with this. I'm not sure. So, so then we have some questions here. Let's see, this is not a tunable coil, and it shows it with a metal core, which is, I don't think it does. So then we have the tuning capacitor here, and its trimmer here. And I would say that these are resonating against this coil. But maybe in fact they're really resonating against this whole shebang here, whatever it amounts to. So, but for sure there's at least one tuned circuit here. At least one. And then of course, that would be it. If there's one here, then there's one at the front of the radio, and then we're right onto the grid of the mixer tube and on its way into the IF. But perhaps this arrangement creates two. I don't know. How can we figure this out? Well, I guess we could, well, I don't know is there anything on this radio about it? No. And we're not going to find out unless I tried to measure it, which I'm not going to try to do, for crying out loud. Measure the inductance of this, go and figure, do calculations. I'm not going to do any of that kind of stuff. I'd much rather take a more empirical approach, hook up some test equipment, run some signals through here, and see what happens. So what could we do here? Well, let's see. I could hook up my sweep generator on the antenna, blast a sweep signal through here, and see what it looks like over here. Could do that. Hooking up, I probably want to get right onto the grid here, on the other side of this capacitor, probably. Now we could do that. Then we could just move from one side of the tube here, where the test may be interfering with all this, to the other side of the tube, to the output side of the tube. Unfortunately, this is the mixer tube, so a lot of stuff happens here. Well, let's try the first thing. I'm going to set up for a sweep through the antenna circuits and try to observe the result here. And we'll just see what we see and go from there. Okay, let's take a look at the coil in question. It's this one right here, and you can see the antenna wire, and you can see where it comes right in here. So let's take a closer look at it. Okay, so let's just go over this. So here's the antenna wire coming in. Here's the capacitor the antenna signal is fed through, and you can see it makes a connection down here, one of the coil terminals. Okay, what's this? So you can see a wire hanging out here, and a wire coming here. It looks like it goes over the top. Is that it coming down to this terminal? So I think the antenna comes in, goes through the capacitor, goes through the coil, and then is grounded. Now, so sure enough, under here on the other side of this of the chassis apron, I can see solder. So I'm going to guess this connection here is actually going out and is actually soldered. It looks that way. It certainly does look that way. And I can see it looks like a wire attached to it here. Look down a little more like that. Just looks like a bump of a wire right there. Oh, yeah, definitely a wire. So I'm quietly looking to see if there's any sign of damage on this, and I don't think there is. So probably then capacitor here connects to this terminal. This terminal ties to one of these two coils. I'm guessing it's this one, the lower one. And the other end of that coil, we can't really see it, but somehow it finds its way to the chassis, just as it shows on the schematic. Now the other coil, almost certainly this one I think, you can see the lead wire literally coming right down to this wire, this green wire. It's like a capacitor down to a tube terminal here, and that green wire is disappearing out a hole, and I'm willing to bet it's going straight to the capacitor. Green wire out a hole. Green wire coming out of a hole. My camera's not focusing here. Well, there's a green wire coming out of a hole. There we go, focused up. Now is that the same green wire? There's another green wire over to the right there. So the green wire I'm interested in would be this one. Oh, it's the other one. So that green wire is connected to the bigger section of the capacitor here, and that's definitely the RF section. The other section is the section that tunes the local oscillator. So the green wire comes up and meets the capacitor there. Ooh. So what can we do with this guy now to check him out? I can see where the secondaries are. Get clip right on the secondary with my scope or something like that. Pump a signal into the antenna. I think at that point I've just made the circuit so different from what it is when it's operating normally. The secondary, so there's that capacitor that goes to the tube, and I talked about getting on the other side of that capacitor. That would be down here. Why don't we start with that? I'll put my scope on here. You don't even have to turn on the radio to do this. Put the scope here, feed a sweep signal into the antenna, see what happens. I don't think it's a terribly valid test, but you know, let's do it. See what happens. You never know. Okay, so what I've done is I've set up the sweep generator. It's sweeping a large range of frequencies down to well below the AM band to way above the AM band. I'm just going to leave it like that for now. Later we can tighten it up a lot and get a much better view of what's going on in the radio. But this is a good start anyway. And you can see the scope behind me there. The scope is set up to work with the sweeper, so the horizontal is being driven by the sweep out over here. It's not running in normal scope, internal scope sweep control method, if you like. And you can't see it yet, but when I do this, there's a little blip on there. Now the flashing and the funny bright stuff you're seeing here and there, that's an effect of the video. It's on the scope itself, that's a fairly steady line here. Let me just see if I can center it up just a wee bit better. And you should see something right there. So I'm going to increase the output of my sweep generator. There, and we got ourselves something to look at. Hey, what's this little guy showing up here? So you're seeing two places where when the like the frequency is starting very low here and then carrying up to very high. It's ending up around 5 megahertz up here, way beyond the range of the radio. So where exactly this is happening, you could take a guess. This is 2.5 megahertz. And the radio can only hear back in here. So what's that? Now maybe that's the tuning spot. I'm going to tune the radio. Just move the tuning control. See which one of those moves. What's the big one that's moving? So what frequency is that at? You can see the height of it is changing dramatically too. Get out here, it gets a lot smaller. What all that means, I don't know exactly, because let's see, I'm tuning the capacitor that we're actually hooked up to, so we are watching the front end tuning for sure. What exactly this is? This is a curious little thing here. I wonder what that is. So it'd be great if I knew exactly what the frequencies were across here, but that's a little more challenging. So rather than have this rise all the way up to 5 megahertz, what if I set it to just 1? No, we can still see this guy here. So he's right around 1 megahertz. And the radio is currently tuned roughly in the middle. So that makes some sense. Let me tune down to, so this would be 500 or 530 or something of that sort. So that's the frequency out here. It doesn't quite add up because the sweep is scanning from 0 to 1 megahertz out here, right there. So, you know, if the sweep is linear, let me check. Sweep is running in linear mode, then this is half of the sweep frequency. Sweep frequencies definitely set to, let me just check here. Make sure I got everything working the way I think it is. So I have to stop it for a moment. That would be oh, went off the scale of my sweep generator. So that's a megahertz. Yeah, definitely. It's getting up to a megahertz. Okay. And starting frequency is way down at 3 kilohertz. 3 kilohertz. Maybe I don't have that quite right. So I'm going to figure out a way that we can mark this frequency very exactly. I want to find out what this is. Is this the IF somehow appearing there? I don't know. How can that be with the way I have it connected? Well, that's why I like doing this stuff, because no matter what you think you're going to see, you end up seeing something a little bit different. So if that second one is 1 megahertz, I can't really zoom in on it too well. I can if I do this. So kind of zoom in on it a little bit. There, that's a better look at it. It's drifting around a bit, maybe because my equipment is not, yeah, it's not stable, fortunately. So the movement there, now it's stable. I'll tune the radio a little bit, and you can see it move. So this is tuned to the limit of 500, what I believe would be 500 kilohertz tuning on the radio. So if everything's correct, this is 500 kilohertz, this point here. So I'm going to introduce another signal generator. We're going to try to identify what frequency that really is. I'll get that set up here. You know what, I can do it. I'll just leave the camera running. It's not that big a deal to set up. It's not that big a deal when you have enough cords to do it with. Let's try this. Here we go. I want this to just basically go on top of what the scope is seeing. Fortunately, when I hook this up, it might knock out the I thought I flipped cameras. It might knock out the scope signal as I connect this. Let's see what happens here. Scope. It'll be right here. Wow, okay, that's not quite what I was expecting to see on there. Not at all what I was expecting to see. So we think this is tuned around 500. I'm going to drop the signal generator into the 500 range. Let me see if something really funny happens here. This isn't at all what I expected to see. Something funny going on here, because this frequency is not changing. You can hear me changing the band switch on the big signal generator. I'm putting in a wildly different frequency. It's exactly the same. That's a hum. I think that's a hum. I think that might be a hum. How am I going to figure that out? And why? Why would you be humming? Okay, the signal generator came off. Maybe I need to put it on the other side of that capacitor. Okay, just a sec here. I cut off the, I think I mentioned that I cut off the antenna wire, so it's a shorty now. Let's clip on here. That's more like what I expected to see. A little reduction in the size of this. Now, I'm going to take a close look at that shape as I tune the signal generator. And what we should see when I get to 500, oh yeah. Whoosh, there we go. So what happened there was, again, I didn't expect this. This is not what I expected. Let me make it less sensitive here. So we'll tune until that signal on the scope is maxed out here. This is not what I was expecting. I guess this is because I'm used to doing this through an IF, and I'm sorry about all the funny Venetian blind things that are happening here, but that's just the scan rate of everything. But look at that. This went up to like that. And what frequency are we at? That's the question. What did we discover? So if we look over here at my frequency counter, 500 and, well, 510 is what that actually is. 510. Interesting. So I did kind of determine that that tuning peak was around 500. The radio is currently tuned around 500. That's the far left of the band spread there. Okay. So what? So I want to see the shape of that curve. So so what I've done here is I've sort of proven to myself it is what I think it is. It's at 500. Let me get this other signal generator out of here. Way off in frequency. Now what's happened to my scope is losing its stability. I was in here the other night fiddling around a little bit, and my sweep generator started losing stability. So it seemed to me. And that could be what's happening here again. So we might be finished at this point with doing what we're doing. Unless I can get this to stabilize. Yeah, I don't know what's happening. Something's happening. Got another piece of equipment that needs to be fixed up. Here. Just pushing a lot of buttons. See if anything at all. Stabilize it. No. Well, even with it jumping around, can we do something with it? What can we do with it? We can't do much with it jumping around, that's for sure. I think I might be stuck at this point until I'm going to have to deal with a sweep generator. Son of a gun. Here, you can't really see what I'm complaining about. Just watch it for a while there. It moving left and right. There's other signs that there's trouble and noise in the signal. I think it's noise in the sweep signal, actually. We can look at the sweep signal and see what it looks like. If I simply set this like this, turn that off, turn that on, now we get a look at the sweep signal. We're on AC. Where did it go? It just drifted off like it's not. Yeah, that's a really strange deal here. Where'd it go? So I think this shows you the trouble here, right here. Where'd it go? Turn it up. Maybe the triggering. No, I'm triggering on the line here. Trigger lights on. Beam finder. It's way up there. Okay. Not exactly sure how it got way up there. And we're going to slow down. We can see the actual sweep signal now that's coming out of my sweep generator. We'll speed the sweep up a bit. There. So when I look on it on here, looking pretty good actually. That looks very, very stable. Why? Okay, back to the other mode. Stable as can be. Or is it? Expand it out. No, you know what? I think maybe it's this control here. Down on the amplitude a little bit. Not a lot I can do while it's jumpy like that. It wasn't jumpy when I viewed it. You know, there's something going on here with yeah, there's definitely something going on. Oh, is that stable? That looks stable. That looks perfectly stable. But when I go to 0.2 or oh, huh. Well, okay. Can we operate like this? I don't think so. I don't think so. What about? No, I'll shrink it. And this probably won't do anything anymore. Son of a gun. Sweep out amplitude. I think it's set internally. I don't think I can change it. Oh. Okay, so that was changing the sweep speed. That's what's going on there. That looks, no. Switch to DC. Yeah, I have a bad capacitor. It's flickering on the video, but it's not flickering. It is a little bit. It is jumping out here. You know what? This is a little better. I think we can work with this. Where's the end of it? Right there. That's good. That's good and stable. It doesn't look stable in the video, but it's actually perfectly stable to my eyes. Now we can examine the shape of this. This is really what I'm after. So I want to stretch this out by reducing the frequency range. There we go. Put it in the center of the screen again a little bit. Now we're almost looking at the same thing we were looking at on the old image, the old characteristic curve diagram we were looking at. Let me tune the radio, just make sure we are looking at what we think we're looking at. Yeah, so I'm just tuning the radio. That's the 500 right there. Well, that's kind of interesting now. If I had the dial on the front of the radio, I could read the frequency as I tuned it across, and I'd know what I'm doing here. Now there's some marks on the front of this radio. There's a 600 mark. I think that's the 600 mark. Let me get the sweep to keep going a little bit further past here. Move it back in the middle. Funny little bump. Again, it's hard to see on the video. So conceivably, this is 600 hertz. I'm going to run that other signal generator across it, and we'll see if it is 600. Do I still have it connected? Yeah. Okay, now this is what I was expecting to have happen last time. You see this point of interference right here. Let me see if I can just clean that up on the camera a wee bit so you can see it better. Just bear with me a second here while I figure out how to do that. If I turn the brightness down, whoops, that was a mistake. Hang on. We'll try turning down the brightness first. That's a little better, right? Yeah, that's better. Okay, now you're seeing kind of what I'm seeing. Perfect. So this is the second signal generator marking that frequency. The second signal generator is running at 588. I'm going to move this interference spot right to this peak. It's kind of obvious when you get there. So right on the peak, and the what's the frequency? Jimith? 530. It says 530 right on there. 530, and we're at the first line. I think that makes perfect sense. I think it's that second line. The first line was setting the pointer at the end of the string, so to speak. 530. This will be 600 then. Let's go up there. What do I got? There. Okay. So now we think we're on 600. The pattern here is moved, but it's so many camera challenges. Here we go. Is it really 600? I'll move the other frequency counter on top of it. The other frequency generator, signal generator, right on top. And of course my frequency counter's gone nutso here again, so I can't see the actual frequency. So we'll just leave it like this for a second and think, what are we actually doing here? We're measuring the resonance of the whole front end of the radio. We're looking at it on the scope at the output. We were looking at it right at the point where the tuning capacitor meets the coil it's tuning against. We're right on that coil. I think that would cause a little bit of interference, but it doesn't seem to. Let me change the scope from times 10 to times 1 to see if we just kill everything. So everything just changed. So you see that that's where we were. This is the resonant area now over here. So what that tells me is, yeah, hooking up my scope and equipment, of course, is affecting these circuits. I mean, it has to. So I'll go back to the times 10, so the effect is lessened anyway. My frequency counter is still just roaring along here. Momentarily it gave a number. Yes, he needs some work. Wow, it's got a mind of its own. I've never ever figured out what it is that's going on. Some component failure or something going on in there. Son of a gun. Maybe it's time for a little break. I'll just stop now. I'll let that settle down. Okay, I had a chance to do a little vacuuming in the house, and I see now this has settled down. 574 is where we're at. I'm thinking that should be 600. So what I can do is I can disconnect the equipment, run the radio, tune it into a known frequency, use the signal generator to make sure I get there. Reconnect the equipment, like turn off the radio, reconnect the equipment, and see if it still reports the same frequency. And what that'll tell me is my test setup interfering with the radio's operation, and I really can't draw any conclusions from what I'm doing. So, because I think hooking up the scope is throwing off the, and that being the case, I'll find a better place to connect the scope and observe what I'm trying to get after, which is to see the resonant shape of the front end of the radio as it actually works and operates. So I don't need, so the signal generator can stay on, but not that one. I want to take the sweep off because it makes a terrible sound. Oh, don't go jumping in there. Like radio's not on anyway. And I want to feed the single frequency scope, into the radio through the antenna, just like any radio signal would come. Good. Knock it back a bit. We think the radio is tuned to 574 right now. Everything disconnected. That needs to be disconnected. Volume down. Here we go. Power. Power on. So the question is this guy really tuned to where we think the front end was tuned? Based on our analysis that it's 574. It's supposed to be 600, I think, under that line. Oh, that's a pretty ugly sound. It's possible we're tuned right on a noise signal. So what I should try doing now to determine if this is picking up 574 is fiddle around with the signal generator. $574. The answer is no. 600. So that tells me hooking up my scope is throwing the resonance of that first circuit off. And there are no surprises in that. The better place to be here is away from the coils and on the other side of the first tube. So the output of the first tube. Problem being, first tube is a mixer. Let's prove the detuning occurs. So if I get the radio receiving here, that's pretty good. That's really sensitive. Huh? This is set pretty low now. Oh, so amazed at how well it's working there. I lost track of what I was just going to try. Hook up the scope. Yeah. See what happens to the stay tuned. Okay, so it went quieter, but it's still there. Did it retune? Okay, so if it retuned, I can tune it back in with this. It did not. It did not retune. It did not retune. It just got quieter. Well, that's fantastic then. So why didn't I find the peak at how come that other thing happened the way it did then? Okay, let's pick up a station. Now, the result of doing this experiment is I may adopt some new testing procedures that I'll apply going forward to radios going forward. That's why I'm doing this. I'm looking for easy things to do to assess a radio that's in trouble. So this is a regular antenna here, outdoor antenna. I'm going to take off the signal generator, put on the antenna. Tune somebody in.
Looking to spend this off-season. Well, yesterday was a really busy day for the Blue Jays, and not just because of Rowan, but they were operating on a few different and they had offers into Josh Lindblom. He ultimately went to the Brewers. They were serious about Rick Porcello. I believe they had attraction with Rick Porcello with just the Toronto. They were interested in him, and ultimately he ended up going to the Mets. So the Blue Jays were looking.
Okay, so what that tells me quite clearly is there's hardly any retuning effect as long as I keep my probe at a high impedance setting or the times 10 setting here. If I put it on a times 1 setting, it's pretty obvious the radio retuned. The resonance point went off, and goodbye to the signal. Retune? Didn't really retune. Detuned the front end of the radio. So we're good. All indications are, hey, this is a valid connection. We can watch the front end on the scope for what kind of signals are in it. Now, shouldn't we be able to see this radio signal on the scope now? Yeah, it's very weak. But let's try. Tuning. Well, you can see something's happening there, but So what are we really looking at here? We're looking at everything under the sun on the antenna. Wait a minute, we're looking at it in sweep mode? Hold on, we're looking at it in sweep mode. Now we're looking at the that's the sea there, eh? So that's a strong noise signal there. I may be able to strengthen up the antenna signal coming into the coming in here. One, I can ground the antenna. Whoa. What did that put on the screen? What's that? Looks like an oscillation to me. Yeah, I'm going to see if I can strengthen the antenna signal here. Just give me 1 minute. Made any difference? Not particularly. Well, that's a good question. What is that weird thing we're looking at there? So this signal we're listening to has a noise signal right adjacent to it. As I tune the radio, let me turn it up a little bit, you'll hear as I just slip away from the station, you pick up a noise. That. So if you listen to it now, there is a okay, a little bit generous here, a sinusoidal tone in there. It's a little noisy, but it's in there, and as I tune the radio back and forth through it, you'll hear the pitch doesn't change. Can you kind of hear it there? So that to me is indicative of this situation I was talking about earlier. We have the two signals close together in reality, and so the distance between them is fixed. When you tune through it, you hear the distance between them. In this case, it's a tone, I don't know, 1500 hertz, would that be? Now, I'm listening now for the pitch changing type tone. I don't hear anything like that. Okay, so we're nowhere near examining the shape of the response curve here. Not when we're doing this. Okay. So I think what I'll do at this point is I'm going to revert to looking at the response shape of the IF, and we'll just fill around with that area for a little bit on this radio. I see I'm getting out towards an hour now anyway, so but let's try that. Okay, so the scope image now, you can see you can't see it. I have the scope input attached to basically the output of the detector at the point where it reaches the volume control. So we should be seeing AVC voltage and audio at the same time. The audio, of course, is the shaky line here. And the AVC, just ground this for a sec. See, no signals right on the 0 point, and when we're listening, you see now the average is down below. That's a little negative DC voltage. That's the AVC. I'm going to tune the radio a bit. You can see that when I tune in, this is just a noise signal generating an AVC voltage. When I first tune in, it jumps down and comes back. That's the AVC capacitor. Very strong noise signals. Okay, back to the station. Now we're going to change the input from the antenna to the sweep generator. As soon as I figure out how to do that. So the sweep generator is sweeping between basically kind of 0 and 1,000,000. That's kind of what it's doing. So now we need this to be set like that, and this to go like this, and this to go like this. And there you see a response curve. I'm going to tune the radio. See the response curve shouldn't really move. What's happening there? Oh, you know what's happening? We're crossing the end of the sweep. The sweep ends at about 1 megahertz. Why we see that big gap there, I don't know offhand. What's that thing out there on the right? Hey, lots of funny stuff to look at. Okay, so I'm going to increase the sweep so it covers the whole band. And I want to just bear with me here while I just make sure it's not sweeping to some completely ridiculous frequency here. Three megahertz, that's a little ridiculous. 1.69. That's good. So I'm just reading the numbers off my thing there. And we're starting at 2300. Should be starting at 53. 2 million. That's 500,000. 540. 540 is just about the bottom of the band. Okay, close enough. Sweep on. Volume down so we don't have to listen to the buzz. Oh, I can't get rid of all of it. We're stuck with some buzz here. So what's that telling us? Tune the radio. It's telling us this is too high. There. We have the sweep completely contained on the screen. Yep. Tune away. the sensitivity here. There. I'm just getting outside the sweep range here. So I'm going to put the radio there, and then I'm going to increase the sweep range a little bit. Didn't I? Did I not increase the sweep range? You know what? I cannot. Yes, I can. There we go. There's a whole thing on there now. Pretty consistent curve all the way across there. What exactly are we looking at? There, that's a way to stop that sound. So I've got the sweep generator sweeping through the entire receptive band of the radio, the whole AM band. At some point it crosses where the radio is tuned. At that point a signal comes out of the detector, a DC signal if you like, briefly, because the signal is not sitting there, it's going by. So a DC voltage is created, but it doesn't have too much time before the input frequency is changed and it's going to come back down again. And that's what's giving you the curve shape there. Why is it moving when I tune the radio? You got me on that. Why would it be seen to be moving? Isn't the IF just always the same frequency? Because the reason it's moving is because the signal on the scope is triggered at a different point in the sweep. So with the radio tuned here, the sweep has to get all the way across the screen here before it encounters the tuning point, and then it produces the curve. Yeah, okay, everything is normal. Good, okay. Because it doesn't indicate the frequency that's coming out of the IF. That's always the same, 455 kilohertz. Mostly snuffed out at the point where I'm looking at it with the scope. The high frequency is mostly snuffed out, leaving just the DC component. So what I'll do is I'm gonna kind of zoom in and expand that on the scope a little bit, and we'll take a look at the shape of the curve. But there's lots of questions about how far you can go with this. Lots of questions in my head. Anyway, sweep on, and we'll expand it now. I think we're operating right at the edge of the radio here. Let's edge of the what's this other peak doing here? Well, that's a curious thing. I'm sure this is the tuning point. It doesn't move, right? Wow, a lot of weird things going on. Oh, you can hear that thing. Oh man, I don't know. This is just exactly what I'm looking for. The stuff that I just cannot explain. It makes me think. Doesn't mean I think these things correctly, but so what is this saying? Is this saying if there was a signal sitting at that little blip point, that signal would be continuously received by this radio nonstop? Is that what that's trying to say to us? This radio's got a permanent tuning spot? How can that be? How can that be? That can't be. Because you're using the local oscillator to do a frequency conversion. It can't be. If there is something sitting there, it can't be in the front end of the radio. It would have to be further on in the radio. And we are examining the output of the IF at this point. Could be in the IF. What would that be? That'd be like a secret little resonance point. That's curious stuff. So what if I get out a screwdriver here with a little bit of metal in it, touch a few key points, and see if this guy doesn't do something. What key points? So in the front end of the radio, we'd be touching stuff down here, like this. Affecting everything. Or maybe this. Nothing. Or maybe this. Or that's the actual antenna. So this is the grid here. There's the second grid. It's probably this one. Oh. Okay. And a few other pins here at the top. So what I'm thinking would happen is if I hit something that's related to just this point, it would do something to this point and not do much to the rest. That's what I'm trying to spot. So we'll go up at the IF here. I'll poke around the IF and just kind of watch what happens here. Get them all. Okay, so that was this tube. The IF tube's way over here though. It's this one here. Let's try this. Try. That's affecting everything. Okay, try this. This one here, here. This one here. I've been all the way around now. That's kind of interesting. Okay, so from there, out of the detector, it's just right into the audio amps. Oh, up here. Wait a minute. Did I get this right? So that's an audio tube. That's a detector tube. Once again, on the detector. And we'll try this tube up here too, why not? This is the inverter tube. Just so far away from the IF at that point that it's not having any effect. I'm way past it now. So, oh, that's gonna, down on my hands and knees there. So that little experiment didn't work. I didn't find anything that was particularly sensitive to that little bump. What would that little bump be? What if I drive a signal into that bump area? I wonder if I can do that. Can I even do that? Think about this. What are we actually seeing on there? Let me turn the sweep back on here. So, what we're hearing coming out of the speaker is certainly this thing. Are we hearing this thing too? Is this generating a small AVC voltage? You know what? I can figure out what frequency that is. How do we know? By tuning the radio. I already know it's... I think it's 455. I'm going to guess. Okay, that's as low as I can get the radio to go. That's about 500. I'll bet you this is the IF here. That would mean the IF... That doesn't make sense. This is the IF. This is always occurring at the same moment in the sweep. Let's measure the frequency of that thing. Or determine it. Can't really measure it. So we're going to put in another signal here. You can see when I hit the tuning point of the radio, explain all that, Jim. Look at that. What's going on there? Oh my gosh, I really I got way more than I expected here. Holy smokes. I can explain all these weird effects. Okay, I was going to measure the frequency of the... you know what, you can't really do it. I can check that. 650. Yeah, that makes sense. This dial is roughly 650. Ah, okay. I didn't go low enough. Now I went low enough. Far be it for me to explain how this is doing what it's doing right now, but it's doing something. So I've now got the signal generator right on top of this curious point. And what does it say? 451. And if I put it up to 4, so that would be 455 right there. So that's what we're seeing there. We're seeing the IF. Interesting stuff, but I can't explain any of it right now. It's all brain teasing stuff. But I like this. I'm going to go away for the rest of the day pondering all this stuff. Pondering it all. Is any of this of any consequence, really? I'm not even sure. I'm not sure where I'm going, but you know, that's pure science operating here. Pure as the driven snow. Okay. I think I'll call it stops here. I got enough in my head, packed in my head to think about. So, thanks a lot for watching this craziness. Yeah, I'm going away to think about all this. Wonder what the heck am I trying to prove here? What are you trying to prove, Jim? Great. We'll see you on the next video where we'll try to prove something. Bye.